Okay, let's talk about the original reason why I started even talking about the Gal 8. We were talking about bullet speed, and just to catch everybody up, one of these gets to birth one of these 65 times a second. And math and physics and high-speed compressible Aero Thermodynamics and all those other big words, I'm just trying to make it simple. These things are going to get really, really hot because they're moving at a supersonic speed. Do you remember all of your speeds? Subsonic is going to be Mach 0.u to about Mach 0.8. Transonic is going to be Mach 0.8 to Mach 1. Supersonic is going to be Mach 1 to Mach 5, and anything faster than Mach 5 is called hypersonic. And supersonic speed conducts a lot of heat and a lot of pressure, which makes things lose its structural integrity, which can make things warp, which can make things melt, which can make things fail, including metal. Some of y'all know where I'm about to go with this. A supersonic bullet has no engine, which means it loses velocity over time. But I want to make a supersonic aircraft that won't lose velocity over time, and it can maintain its structural integrity as best as possible while in flight. What metal can I use? Well, the metal with the highest melting point is tungsten, 3,400 degrees Celsius. But tungsten is very dense, which would make this aircraft ridiculously heavy. Next up, molybdenum, melting at 2,620 degrees Celsius. Ever heard of it? Yeah, it's that rare. Good luck building aircraft. Fine, how about chromium? It melts at 1,860 degrees Celsius. Again, that's a very dense metal, which would make an aircraft ridiculously heavy, which means that you need a bigger engine to push all that weight, which means more metal, which means a bigger engine, and you just don't know. I'm about to give up. Next up is titanium. It's got a melting point of 1,670 degrees Celsius, thereabout. Can we make a supersonic aircraft out of that? Wait a minute, it's a light metal. And it fights corrosion? Can we make an aircraft out of that? I'm glad you asked, wingman. Meet the SR-71 Blackbird. But all that pressure would make the metal expand. So you gotta put in a few gaps, like this one right here. And with all of the gaps being filled and the plates pushing on each other, would make this aircraft grow about 6 inches in flight. Ladies. Science, technology, engineering, and math moves us all. I love talking about stuff like this because one day I'm actually going to talk about gravity and gravity weapons. Who's all ready to join the Air Force? Have peace and love.